Okay, this is my presentation on source filter theory. So first of all, what is source filter theory? It is the mechanism that explains how sounds are created in the vocal tract. So first of all, let's talk a little bit about the vocal tract. It is a quarter wave resonator, which just means that it's closed at the glottis and it's open at the lips. It's also a variable resonator, so that means it changes shape by moving around the articulators and the cavities, which basically results in just a variety of sounds being created. And so in the vocal tract, we have this series of cavities or air-filled cavities, which are just another way of saying resonators. We have the laryngeal cavity, the pharyngeal cavity, the oral cavity, and the nasal cavity. And each of these cavities resonates at its own frequency or formant, and they act as a filter. So with the constriction of valves, this changes the shape of this vocal tract tube, and therefore the formants change of each cavity, depending on how you alter the shape. And you can alter that shape also by constricting valves, such as the laryngeal valve, which is at the level of the vocal folds, the velopharyngeal valve, which is at the level of the velum, the lingual valve, which is at the level of the tongue, just by constricting the tongue, and the labial valve, which is at the level of the lips and teeth. So, source filter theory has three main parts. The first is source function, which is just the glottal sound that is produced before any filtering has occurred. And that's represented here in this input spectrum. So it's just the sound that occurs before it undergoes any filtering, and it might just sound like a buzzing sound. The second part is the transfer function, which is represented here on this resonance curve. And this is just the vocal tract resonator, basically. So as you can see here, it shows each of these peaks right here, 1, 2, and 3, are the formants, or just the resonances at each frequency. So this peak would be the highest amplitude at about, 500 hertz. This one would be at about 1500 hertz, and this one would be about 2500 hertz. And then the last part is the output function. So this is just the sound source once it has been filtered, as represented in this output spectrum. So the same fundamental frequency and harmonics that were present at the level of the glottis, the glottal source, will be still present at the output, but the harmonic amplitudes will have been filtered and modified, and thereby changing the sound that comes out. So it's basically the combination of this glottal sound source with different filters that occur at each level of a cavity to create a different sound. So let's look at a specific example with the vowel E. So you, of course, start with the glottal sound, the sound source, as represented here. And then the sound will travel through the larynx up to the pharynx, where the sound will, the velum will be closed, the velar valve will be closed, so the sound will go through the mouth, which would be here. And here is where the tongue, the E vowel is a high front and relatively closed vowel, so the tongue will be kind of towards the front and upper part of the mouth, and the lips will be kind of stretched. So that's where those kinds of constrictions occur, and it's changing the shape of that oral cavity. And because the velum is closed, we're not using the nasal cavity. And then the sound output is seen here. So that's just what is occurring when we're taking the sound source from the glottis, having this formation in the vocal tract, and we get this sound output. And so for females, as it says over here, and it's kind of hard to see on this, I couldn't find a bigger picture, but for females, the first formant is typically around 310 hertz. So you can kind of see that reflected here. This is in kilohertz, by the way. And then the second the second formant is about 2,790 hertz. So you can kind of see that with this peak. And then the third formant is about 3,310 hertz. You can kind of see it there with that peak. So we have 1, 2, 3 formants. And then on this slide, this is just another image of the vocal tract filtering system. So as you can see, the E vowel, this part of the vocal tract remains relatively open. You have the velum is closing off the nasal cavity, and then the tongue is in this position. The lips are kind of stretched, and these different shapes are creating different resonances, or resonating with frequencies in the cavities and creating the E sound. So that's also shown here on this spectrogram. Darker spots indicate amplitude. So you can see here is the first formant, second, third. And then the source filter theory of the nasal sound. So the sound is going to be a little bit different than vowel production. It does have a periodic glottal source, just like a vowel, but its amplitudes are going to be lower than that of vowels. So it'll be similar to like a voiced stop, except air is also going to flow through the nasal cavity, as we know. So if you can picture, we have the vocal folds down here, the glottis, which is our sound source. So we're creating that buzzing sound, and then it's going to pass through the filters, or our air-filled cavities, so up through the larynx, and we have the velum is open this time. The velar pharyngeal valve is open, so now air is allowed to pass both through the nasal cavity and through the oral cavity. But in the M, we have the bilabial lip movement, kind of stopping the majority of that sound, and so the majority of the sound passes through the nasal cavity. So all of this is acting, this opening or closing of filters. So we have the opening of the velopharyngeal filter, the closing of the labial filter. All of these filters are changing the sound that will be produced, or that's coming out, the sound that we hear, when it combines with the sound source from the glottis. And my references, just the chapter 2 of Ferrand, and I hope that was a little bit helpful.